What's up guys? So today I'm going to be installing this Tesla wall connector inside of this garage. So I'm just going to go through quickly. I've seen quite a few videos talking about this. I'm just going to show you the way that I like to do it. Generally speaking, not every application is the same, but this is a pretty common way for me to do it. It works great. We're going to be putting it in the garage here. As you can see, we got a little sub panel. We're not going to use that. They were actually nice enough when they built it to leave this chase here. Unfortunately, when they added this solar run here, they drilled right through the chase and ruined it. So that is not an option. So with that in mind, I thought this would be a good example of how to do it simply, save some cost and just keep it simple. So we're back out here on the outside at the main electrical panel. So luckily we do have plenty of slots here, plenty of availability. I'm going to go ahead and open this up. So now that we have the panel open, we can see we have quite a bit of room in here, even physically speaking on the side. Just here's my hand for reference. There's quite a bit of space in here. So you're going to need a 60 amp 2-pole breaker if you want to have the full function of the charger. So here we have the Square D home line to match our Square D home line panel. Anyways, you're going to be installing that, but what we're looking for is a route to the garage, and obviously the quickest and safest route really is through the back of the panel. So I'm going to go ahead and try coming through right here. Hopefully it works out. Should be okay. They usually frame out for the panels. So we're going to go ahead and get this hole going, and we'll show you what it looks like. Alright, so we have our little pilot hole that I started with here. You don't necessarily just want to go crazy with your hole saw or unibit right out of the gate, just in case you realize you need to make an adjustment. But jumping over here to the garage side, we can see that there's definitely adequate space here. Here's our sprinkler timer. So we'll be able to get the wall connector into this space here, no problem. So we're going to go ahead and get this sized out for the proper size connector. Alright, so we do have our hole through the wall here. We ended up installing a little nipple straight through. I just use a unibit to drill. You can do it with a hole saw too if you don't want to pay for a unibit. So there is a few things to keep in mind as far as when you're mounting this. First of all, depending on how they framed out your panel, there might not be a lot of space between the back of your panel and where you're mounting this. So keep in mind what kind of anchors you're using. You definitely don't want to screw into the back of your panel, so just watch out for that. Luckily I was able to use some drywall anchors here, and that's why we have 4 of them. I usually like to use toggle bolts, but unfortunately there's no pop out. Sometimes there's pop outs, something like this where you could get a toggle bolt in there. Anyways, this is going to hold it. It's locked in nice and tight. The nipple's installed. One other thing that's a little challenging with this is if you look at it, there's really no actual straight edge. So this could get kind of, depending on how OCD you are, what I would recommend is maybe you just make a center line and level it, and then you can align the top and bottom centers if that's going to bother you. Alright, so we got our wires landed here. Basically, it's going to be the 2 hots and a ground. So if you follow around, I still got to tape it green. But anyways, most number 6 wires will fit in your ground bus. Your typical ground bus will accommodate that without a special lug, like a bigger lug like that is not usually necessary. Anyways, all that to say, there's your power. This is going to be our 60 amp breaker right here, and then it just loops into here. You do want to use number 6 gauge copper if you're using copper, and if you're using aluminum, then check your respective rated chart to make sure you're using the right size wire for the insulation type that you have and the conductor. Jumping over to the actual connector side, pretty much this is the ground here, the left side. This would be your neutral if you're running like a 120 volt system. But really, if you're investing in one of these, your customer is going to want all 60 amps of 208 or 240, whatever you have. So anyways, these are your two hots here. And then you just tighten them down with an Allen wrench, as you could kind of see there. So not too crazy there. So now I went ahead and mounted this connector to the wall, and it pretty much just slides on. There's some fins that go into the slots as far as the power. What I will say, what I want to draw your guys' attention to is these screws here. There's some Allens in the top as well as the bottom. Seems like it would be pretty easy. It's not terrible, but getting them to line up and thread in is a bit challenging, and it's really important you get them in there because that's what keeps your connection from the fins into the connector good. So without those, you're essentially, it's just going to fall off the wall eventually, but you'd also have a loose electrical connection. So anyways, you want to make sure you get that right. And now we're just going to go ahead and do the startup. So we should be able to come around over here. So I just went around and energized the circuit, and as you can see, we're doing our startup here on the wall connector. So that is really all there is to it. It's doable if you're trying to do it DIY. Obviously be careful, turn the power off, but really all you need is a 60 amp breaker, some number 6 wire, and a path to wherever you're trying to mount it.